Okay, hey, thanks, Alison, for your invitation. So today, I'm gonna talk about the Beat Army One outbreak happened in South Korea in 2018. And so again, I'm Yong-Lak Park from West Virginia University. Somehow I'm in Korea right now. So let's see. Because I'm the first speaker talking about drones today, so I'm gonna introduce about drones very quickly. So we have a lot of different names for drones. So, traditionally we says unmanned aerial vehicle, UAV, or unmanned aerial system, or UAS. But in the United States of America, USA, we use SUAS, which means a small unmanned aerial aircraft system. And this is actually official term used by the Federal Aviation Administration of the USA. And then, traditionally we say, RC or RCA, remotely controlled aircraft. So in terms of types of drones, we have two different types. So one is rotary wings, which means, it can hover, it can stay in the air so that we can focus, taking picture, detailed picture. And drones can go up and down slowly and fastly. So rotary wing drone has a kind of advantage of, staying in the air and then, observing the phenomena very closely. We have a fixed wing drones, which means it's like airplane, right? But it can fly very fast and it can cover a large area because, it fly very fast, basically. So depending on mission, we can pick to choose which drone is the best, So drone is just the airplane. So depending on what sensor you put in, it determines the functionality. So for example, if you put thermal sensors, now you are, observing heat signature of your object on the ground or in the tree. So, also you can put like a pesticide. In the case, drone can be pesticide applicators, or you can actually put natural enemies. In that case, it can be used for biological control. So those are the things the next two speakers will talk about. So, but my point here is drone is airplane, and then you put something into the drone, and then it make drone more useful, especially in agriculture. So in our project, we don't fly drone actually. So basically we program it and then it fly automatically. So we push a button and then the airplane, drone flies and then do the job. How can it do that? Because drones are guided by satellite. So we can command, go there, take a picture, and then go there, spray pesticide and return back, and they will do it. It's called autopilot or autonomous drones. That's what we do. We generally don't fly drone, basically, interestingly. So today, what I'm gonna present is a beet armyworm. So it's a Cephaloptera exigua. It's a Noctuida family. So it has more than 90 host plants, including beans. Generally, first and second instars after hatching from the eggs, they are very susceptible to pesticides. So growers try to kill the very early stage of these insects. And in Korea, the problem what they have is large-scale migration from China. So in the spring and early summer, the wind blows from China to South Korea. And then these insects, the adults, moth, take up with like a wind and the land in South Korea. So as of today, South Koreans think this insect cannot overwinter in South Korea. So if they have a problem every year, it's coming from China. So how to manage or control these insects? The most important thing is early detection and rapid detection, so that they can kill the first and second instars. So that's what South Korea has problem. Okay. So in 2018, I was in sabbatical leave from the United States and to South Korea. And in late July and early August, fortunately or unfortunately, there was an outbreak of the beet armyworm, especially in the western part of South Korea. So this, the damage was so extensive, so the government, South Korean government, made an emergency corps for rapid assessment and control. Otherwise, the bean growers in South Korea, especially in the western part of the South Korea, will have a big problem. So what they did was they have actually interagency survey team for ground survey. So basically they sent 19 people out in this area, and then those people go and look for beet armyworm damage. Okay. So again, it was bad news for South Korea, but it was a good opportunity for me, so that because I had the drone with me at that time, so I could do area survey for them. So basically, what I'm gonna present today is the comparison between ground survey, conventional ground survey that the South Korean governments do versus area survey, what I do in terms of detection and assessment. So if you look at the damage by beet armyworm, so they're defoliator. So basically, they removed leaf tissues. So you can easily see it. You can easily assess it. But that's A and B. And if you look at the aerial view, the C is the actual drone image, about 5 meters from the ground. So actually, if you look at in detail, you can see like a feeding damage, feeding holes and all of those. On the right, that's actually about 50 meters above the ground. So that now you can see the damage of the field, not individual plants. So this is actually the technology we had in 2018. So one more time, we don't fly drones, so we program it. So basically, we do aerial survey with the autopilot, and then we download the image from the drone, and then we align the image and stitch it together so that we can have one big map of the area. And then now we georeference it, and then we can put in the geographic information system, which is called the GIS. And then that's that's very normal procedure for drone flight. But we did one more thing. We did a very low altitude flight to make sure the damage is actually done by the insects, not other things. And then based on that stitched image, we did image analysis and to extract the bean foliage, which means a healthy part of the plants or in the field. So we estimated bean defoliation. So this can be done in 1 day. So that's the kind of rapid assessment of beet armyworm damage in South Korea. So I'll go a little bit detail about the autopilot. So this was the flight path of our drone. So actually it flies like a serpentine pattern, again, automatically. And then that's the first flight, about 50 meters above the ground. And the second flight was really low altitude flight, 5 meters above the ground. And then we give this kind of path and then taking picture or videos while they are flying. So that we can make sure the damage is actually done by the insects, not other things. So having 50 meter above ground flight and 5 meter above the ground flight, so we can make cover large area. At the same time, we make sure about the insect feeding damage. So this is an example on the left. So this is about 5 meters off the ground, and actually you can see the defoliation really well, and this is done by insects. And then on the right, 50 meters off the ground, and now you can see this beam block is a little bit greener, which means less damage, and then this beam block is completely gone, right? So this is how we did it. And this is a variety of damage we saw in 31 beam blocks. So, like a D is completely, healthy. There's not much damage. But if you look at C here, it looks like they didn't plant it yet, right? But no, this is actually defoliation, complete defoliation. Even they eat the stem. And then if you look at the E, this is very interesting. On the left, the bean is okay, but on the right, there's a big damage. So there may be a variety of differences of the bean, right? So this is actually the stitched image of the area we flew. There are about 31 bean blocks, and then you can see really green blocks. Those are paddy rice field. So beet armyworm don't eat rice, so rice is really green. And then, but can you see all of this area is heavily defoliated? So what's next? So we did the image analysis, and then to extract the green foliage. So basically, the red colors, the redder, is more healthier, and then grayer is more unhealthier. So that's the kind of idea. Okay, and then so this is actually 31 blocks, 31 bean blocks, excluding paddy rice field. So what you see here is there is a 99.9% damage. This is complete damage. We generally don't see this kind of 99.9% damage. But some blocks, there's only 23 or 24% damage. I said only, but 23 to 24% damage is still really, really high for growers. So this is actually the result of the area survey. Okay, so now Korean governments were interested in what I did, so they asked me to do simple economic analysis, so that they can see how drone technology can be used for this kind of rapid assessment of the bean damage in this case. So basically, it's simple. Like this is an area survey cost is like there is a flying time, right? And there is an image analysis time, and then there is an expert. There are experts who can fly drone, and then who can do image analysis. But at the same time, you have to have a drone too, right? So we call the technology fee. And then divided by number of blocks. So basically, this cost is per block. And we used like a $50 for expert fee, drone renter and the software renter. It's kind of general amount. So this is actually the cost associated with the drone flight and image analysis. And also we have a conventional ground survey, which is labor, right? And then time in the ground and divided by number of blocks. So this will be the ground survey cost. So in general, in Korea, again, in South Korea, what they do is they examine 30 to 50 bean plants per block. And then they do 5 categorizations: severe, high, medium, low, and no damage. And then they calculate average. So it's similar to drone survey, but they only look at 30 to 50 bean plants per block. So anyway, so this is the result. So y-axis is time. So how long it takes time to survey this many number of blocks. So for example, like if you have 10 bean blocks to survey, it'll take about 10 hours. But in the ground survey, but if you use a drone, it'll take maybe 10 minutes. Right. And then again, the more block we have, there will be more time for ground survey. But in terms of drone, because the drone is already in the air, right? Just covering a little bit of larger area, it doesn't take up more time. So this graph says drone is much faster. It's good for rapid assessment. So y-axis is the cost now. And if you look at this, and the dotted line is ground survey, and then this line is area survey. Again, x-axis is number of bean blocks. So if there are 15 bean blocks to survey, so the cost for area survey and ground surveys is equal. But if you have more than 15 blocks to survey, then drone is more economical. But if you have less than 15 blocks, then ground survey may be more economical. So if you look at this area survey, they already start $150 because of technology fee. You have to have drone flight, the drones, and then pilot, and even image analysis later. So, okay. So based on our study, basically what it says is drone is good for rapid assessment. And then also if there are more than 15 beam blocks, definitely drone is more economical. So that's kind of the main result. So based on this study, why, so this small area, the black area, that's the area we studied, but we extended our, the observation area with satellite image, because the satellite image can provide some sensors. So in this case, we use the Landsat 8 MODIS. So this actually MODIS sensor is calculating normalized difference vegetation index. Basically, they are kind of, detecting the green healthy vegetation. So for example, before outbreak, so there are some greens. Green means more healthier vegetation, and red means no vegetation or less vegetation. So, in early July, there, crops are still growing. And then B, if you look at B, there are more greens for sure, because crops are growing, growers are planting. And then in September, it's more green because, crops are growing again, right? But if you look at this area we surveyed, and it was a green and become like a reddish, which means they lost basically green healthy vegetation. So based on this, we can calculate where the beet armyworm outbreak occurred, and this is where beet armyworm outbreak occurred in that area. So again, so a satellite image is good, but you have to go and do the ground truthing to make sure that is done by insects, not other things. Okay. So this is my take-home message. So a drone technology is already here. So even there's autopilot function, which means you don't have to fly drones. So that's actually a good thing. Data analysis, auto detection is very common these days. You don't have to worry about it. However, interpretation and assessment, we still need experts, just like entomologists. So based on this, rapid assessment of insect outbreak is possible using drones and image analysis. Surely, we are working on deep learning and all of this machine learning to automate all of these processes. So that's kind of near future thing. So again, I'm not Korean even, but I was in Korea, fortunately, unfortunately, where a beet armyworm outbreak occurred. And these are the Korean agencies who did the ground survey. And these are the funding sources. And then I hope actually my presentation is helpful. It's not fall armyworm, but it's very close to fall armyworm, which is a beet armyworm. So thank you so much.
Excellent. Thank you very much, Dr. Park. That was fantastic. And it's okay that it's not fall armyworm. It's a bit weird for me to see BAW rather than FAW because I'm so used to fall armyworm. But no, we're interested in the technology and the use of this for pest management in general. And yes, it's extremely interesting. So I'm sure there'll be some questions, but I've got a question because I know you're working on drones, other sort of research with drone use, I believe. Are you doing, what other work are you working on in this sort of field?
Yeah, so actually, I started my drone research in 2009. So it's about, 15 years already. And we started with biological control. I think the third speaker will talk about, releasing natural enemies, but we did a study in 2015 and published 2018. I think that's the first paper about biological control. But this was the problem. So we started this kind of drone project so early, but in the United States, in the USA, the policy is so behind. So even you cannot fly drone sometimes, and even you cannot, release anything, drop anything from the drone. So even pesticide, there's so many things you have to steer. You have to get multiple licenses and permits. And then, releasing natural enemies, insects, right now it's okay, but until 2018, it was totally illegal. But again, this has been the better and better every year. So during the last 5 years, what we have been working on is the detection of invasive pests, insect, plant disease, and weeds using machine learning. So that's actually what we have been doing. So this kind of, the presentation I gave you today is a little bit old kind of technology compared to what we are doing right now. So.
Oh, well, that's excellent to hear, because we'll invite you back to hear the more recent technology and the machine learning, because that's really interesting. So we will invite you back for that. So that's a promise there.
Sure.
I've got some questions here. So we'll launch into a few of these. We'll have to be quite quick because we've got a bit of a time pressure. But here's one: drone surveys may help for detecting very high damaging insects like Spodoptera, brown plant hopper, etc. What about other insects like Helicoverpa and diseases?
Okay, so you need to be very careful about when we say detection. So are we detecting the damage of insects, or are we detecting insect itself? So there's two different things. So right now, the technology, or I have to say hardware and software are available to see insects on the plant as well. So in the past, we tried to, use the kind of the airplane or satellite, which means damage needs to be very severe. Otherwise, we cannot see from the sky and space. But now we have a drone technology. We fly low, but now we can fly extremely low because the drone has anti-collision sensors. So even you can go down to 1 meter above the canopy. So we published a couple of papers about detecting insect itself directly, so that we make sure not only just detecting damage, but also detecting insects. So we can make sure what insects are making that damage. So,
oh, wow. Fantastic.
Yeah, fall armyworm is actually I think it's kind of relatively easy one to detect in terms of that damage, because their damage is so high and extensive. But directly detecting insect may be a little bit difficult because they are not generally exposed. So yeah, but there are insect. Yeah, there are insect exposed, like for webworm and tent caterpillars. Those are exposed, and then actually you can see it.
Oh, excellent. No, that's great. And that kind of follows up a question here, a couple of questions related to the reliable detection of pests which cause less obvious damage to crops. So there's a question here that you mentioned that the L1 and L2 larvae stages are most susceptible to insecticides. But do these small larvae already do enough damage that you can detect by drone?
Right. So that's a really good question. So only rapid detection is very important, right? So you do very quickly covering large area. So that's we call the rapid detection. Early detection is another thing. Early detection means when damage is small, you need to detect it. So for the invasive insect management or pest management, early detection is more important than rapid detection. So anyway, so in terms of early detection, when the damage is small, because the damages are small, the drone has to fly low to see the damage, right? So there is actually, but if you fly low, the problem is you cannot cover large area. So there is a pros and cons. If you fly high, you can cover a large area, but you cannot see detail. But if you fly very low, you can see very detailed, but you cannot cover large area. So that's why the study I showed you is, what altitude is good for, early detection or rapid detection or, like a detailed detection.